Alright, let's do some review. Regular polygon, that's a polygon where all the angles are congruent, all the sides are congruent. So the formula is 180 times n minus 2. That'll give you the sum of the interior angles. So let's say you use the applet and you get an n equals 8. So what I'm going to do is to find s, that's the total interior angle sum, so that's the first part. 180 times 8 minus 2. So you can use your calculator if you want to. So that's 180 times 6. 180 times 6. And that's 108. Oh, sorry. 180 times 6. 1080. So 1080 degrees. 1080 degrees. So then one of the interior angles, that's the second part, is 1080 divided by 8. That's 135 degrees. And then the exterior angle, that's the last part, is 180 minus 135. So that's 45 degrees. Alright. Use the applet. If you don't come up with something, just do n equals 14 or whatever. So next one, if the measure of an interior angle of a regular polygon is 140, find the number of sides. So you've got this polygon, you don't know how many sides, so n equals, that's what you're trying to find, but this angle is 140 degrees. We know that 140 times n, that should give us s. We also know that 180 times n minus 2, that will also give us s. So if I solve this for n, then I have my answer. So that's what I'll do. 140n equals, now distribute, 180n minus 360. So that's negative 40n. I subtract this from both sides. Now I'm going to divide both sides by negative 40. So that's 9 sides. Alright, next one, if the measure of an exterior angle is 40 degrees. So again, I've got a polygon, don't know how many sides. I'm looking for this, alright, I know that this angle is 40. So in here, I've got 140 because those angles are supplementary. So this becomes the same problem as up here. So again, n equals 9. But the key here is if you know the exterior angle, what's this one, and use that to solve. Alright, down here, PQR, that's this angle, that's congruent to this one. So angle PSR. PST, so that's this angle in here, that's congruent to this one. So angle TQR, because those are alternate interior. PS is parallel to here. QT, that's congruent to TS. So to use any of this, I have to know that this is a parallelogram. So PQRS is a parallelogram. So those two we just talked about. Then other congruent angles, you can look here and here, you can go here and there, you can go right here. You got all kinds of options. Alright, let's do the back now. Up here, I'm going to write an equation and solve it. So PMN is 64. PMN, right there, that's 64. I'm looking for MNO. I know that those are supplementary. So 180 minus 64 gives me the measure of MNO. Alright, so I'll use that to solve for that. And then NOP, that's the same thing as PMN, so I know that that's 64 degrees. Next, MNO is 3x plus 12. PMN is 2x plus 3. I know that those equal 180 when I add them together because they're supplementary. So this plus this equals 180. I wrote an equation, now I'll solve it. So we got 5x plus 15 equals 180. Subtract that, so 5x equals 165. And then I divide both sides by 5. So x is 33. Next one, if PD is 17 and dn is this, find x. Well, I know that those are congruent, and that's what's going to help me solve. So 17 equals 3x minus 1, then solve that for x. OPN, so that's this angle right here, that's 4x minus 10. And PNM, 2x plus 6, those are congruent, so I just set those equal to each other. And solve for x. Then the last one, PDO is 84. I suggest that you write this in. So that means this is also 84 degrees because those are vertical. PMD is 25. PMD is 25. And I'm asked to find MPN. So I want to find MPN, this one right here. So let's call that X. Alright, so those are vertical, these are supplementary. So that 180 minus 84 should give me this angle. So it's 96 degrees. I know this, I can find that pretty easy. So x equals 180 minus those two added together. Alright, next. Determine if each one is a parallelogram. So you're going to use your notes from 6.3. You've got those 4 properties, or those 4 theorems. I want you to write out why it is or is not. So on this one, that is because I've got opposite angles congruent. Opposite angles are congruent. This one, yes, because these are congruent. 5x and 5x, 6x and 6x. So the diagonals bisect each other. Next one, I've got opposite sides are congruent. So opposite sides are congruent. Here, this one is, oh yes, yes. This one is because I've got a pair, so one pair of opposite sides is parallel and congruent. And then down here, no, I don't have enough information. This doesn't match up with any of my theorems from 6.3. Alright, that's it. Let me know if you got questions.